Welcome back to our Zivid lab. Last time we talked about parcel induction application, and today we're going to see manufacturing applications. We're going to test and to take capture about some point cloud of typical objects we can find today in the manufacturing area. Manufacturing covers a broad range of areas. Bin picking and machine tending, when we want to pick the same object in the same bin, typically some shiny metallical parts and objects. Assembly during the production phase. Inspection, such as metrology or dimensioning. And robot guiding for surface finishing applications, such as grinding, welding, etc. So to perform this test today, we're going to use the Zivid 2 Plus Armor 60, which is a camera which it's part of our last series of Zivid cameras. We want to use the camera because it has narrow field of view and a smaller working distance range as well. It's the best camera we use today for inspection when we talked about high accuracy requirements. All of our cameras from the last series are made for industrial purpose, so they are industrial grades, and they can perform at very high speeds. Okay, so let's go for our first point cloud. Here I select the Zivid 2 Plus Armor 60. Connecting, I choose the presets and I capture. So here's the point cloud we get, increasing the point size to see a little bit better. So in this case, we have kind of like a scene which is made for bin picking. So we have the same kind of objects which are stacked together. We have these objects which are shiny, metallical, flat objects. The task of the robot in this case is to come and pick the objects and empty the bin. In this case, we decided to use the Sage engine. Sage engine, it's a vision engine which has been developed to tackle the reflection we can have into a scene. For example, here we can see that we have on the top of the bin some reflections have been handled well with our cameras. We also sometimes have some specular reflection and inter-reflection in between the objects. So that's why we choose that preset, specular, within the category of the manufacturing. Let's have a look more in detail about the point cloud. So here we have good coverage on all over the objects. Let's talk about edge sharpness. So when we detect and localize the parts in manufacturing scenes, we need to often compare the 3D point cloud to a CAD model or a template of the part that the system uses as reference. The system is looking to match specific features and shapes so that it can work out how the part is positioned and it's oriented also as well. For this to happen effectively, the camera has to deliver sharp and crisp edges in detail and also a good resolution. We have sharp edges on these flat metallic objects, and we have good resolution as well. Now let's have a look on the HDR. So these parts can be very shiny and have a lot of contrast inherent. So to ensure that you can get good 3D data consistently and across the whole scene, you need a 3D camera with the wide dynamic range. The Zivid 2 Plus R series, so in that case the MR60, have very good HDR characteristics, and they can deliver more than 80 decibel of dynamic range with a single acquisition. When we talk about multiple acquisition and HDR in that case, we can go up to 130 decibel. This is beyond the range a human eye can perceive. So here, second point cloud, I use the preset semi-specular because here we have a scene with an object, a big object, metallic, which has some reflections and also requires a big dynamic range. We have here a scene which is represents a robot guiding application where the camera is mounted on arm, so on the robotic arm. For example, kind of application, we can find our grinding, sandings. So you need like a good coverage, good resolution as well. We don't have noise in that scene, no reflection artifact neither. Final point clouds. When we talk about parts with tiny features and very small details or holes, we could consider that application as like inspection. In this case, that's the preset we used, inspection, small features. That preset has been developed for this kind of scenes with reflective parts, with small and detailed features such as components like we can have like on PCB boards, like in that example. We basically like are like be able to go like under sub-millimeter precision with our cameras. We are also able like to detect thin wires, can be like 1 millimeter thickness. When we are in inspection, the camera is mounted on arm, and here we can talk about robot mounting flexibility because the closer you are, the best it is. And for inspection, the MR60 is the best fit you can have, which means like you have the focus distance at 60 centimeters. And every time you want to inspect, you can basically control the working distance you're having while capturing with the cameras. And here on the right side, you have that metallic and shiny parts with holes. So when you need to make like to get screws in the holes, or when you need like to definitely assemble that part on a bigger piece, for example, we have a good coverage on that point cloud. We're able like to see the sharp edges and even able to see the thin layers, like here, for example. But wait, one very important point as well. We want to care about in warehouses, in factories. It's the ambient lights. In general, what we have, it's like in average, approximately in terms of like lux, we have 300 lux in warehouses and factories. That's what we can measure, and you don't want really like to care about like how you have to position the camera relative to the ambient lights, or if you'd like to add external coverage of covers like to make more shadow into the scene. That's what I wanted like to showcase here with that last point cloud. It's like with the same scene we had in the first point cloud with these flat metallic objects. I put an external light which is very bright, and we want to show here with the R series the feature we developed here and with the improvement we made is like we have a very good resilience to emit lights. Today, it's the unique feature you can find in the 3D camera market. And here, if you look at the point cloud, we can see that we have this. We kept like we have the same consistency, and even like if we project a lot of brightness and a lot of light onto the scene, we wish to keep 3D data quality. So it's good to talk about point cloud precision, point cloud data quality. But it's very important to know that our cameras are, as we said, industrial grades, and they are hardly tested. We do some vibration and acceleration tests. We also do some drop tests, and these tests like can last over like 100 of hours. Why? Because today, when like you want to deploy our cameras in the industrial environments, these places can be very rough, and the camera is going to be moved a lot, mounted, unmounted, and that's why robustness is very important. I would also like to talk about the importance of the robot-mounted flexibility. Our cameras are designed to perform either in a static mounted configuration or directly mounted onto the robotic arm. When our camera are mounted stationary, it doesn't present much of a challenge. It requires to be mounted on the stand correctly. It means like out of the clearance of the robot and at the right distance to be able to perform good data quality. However, when we mount the camera on the robots, it's another story. The camera needs to be compact, have a light weight to not overload the robots, does not like restrict his range of movements. When the camera is mounted on the robot, it needs to have a very good calibration stability because it will experience some movement, some vibrations, which will definitely affect its performance if the camera is not well enough designed to do the job. 3D cameras are very sensitive pieces of equipment that work down to very fine sub-millimeter measurement levels. It is normal that environmental changes will alter their ability to deliver accurate informations. This means that a really good 3D camera must have countermeasures that adapt to changing conditions, most especially temperature, to compensate and remain accurate. Our Zivid cameras have a novel and unique dynamic calibration system that adjusts for temperature changes and maintains the camera at high level of calibration correctness over the time. To sum up at Zivid, we have three general considerations when it comes to point cloud data quality: the correctness, the completeness, and the cleanliness. For our end customers, achieving these three considerations is a key to deliver a successful application. I would also like to remind you that for manufacturing applications in three divisions, the camera needs to have a good calibration stability, a good robot mounting flexibility, and a very good robustness. That's what you can have today with our Zivid cameras. Thank you for watching. I hope you enjoyed. If you would like to know more about our cameras or image some object in your specific application, don't hesitate to reach out to me for a personalized demo.